Last up for this chapter section, we're going to take a look here and consider the triangle angle bisector and use it to solve problems. So an angle bisector is a triangle that's, an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the length of the other two sides. Let's repeat that. An angle bisector in a triangle separates the opposite side into two segments that are proportional to the length of the other two sides. So JM here is an angle bisector, and we can see that it's an angle bisector because we got congruency, or indicated that these two angles that the JM intersects are congruent. And that being the case, we have proportionality between KM, this side, this segment, and LM, this segment. So we got proportionality for them. So in other words, KM over LM. But as well, we have proportionality with KJ, this side here, to LJ, this side here. So since we've got proportionality, we can use that to solve problems. And so let's take a look here at a couple of problems, examples of what we could solve. So now here on this triangle on the left, and let's see, this is cut off a little bit. I cut that off. We're indicating that the length of this segment to this midpoint, or to this point of intersection here, is 4. It's not a midpoint because they're not the same length. And this segment here is 6. Okay, so we got proportionality between this, and then we got proportionality for those two sides there. So let's do this setup. So we've got 4 over 6, and you could put 6 over 4. Now order is important. Since I put this one first, I want to use the x here in the numerator over 13. Okay, well now let's solve. So we got 6x equals 4 times 13. Let's see, 26, 52. 4 times 13 is 52. 26 twice, okay, 52. Let's divide both sides by 6. And 6 will go into 52. Well, let's see, 8 times 6 is 48, so it goes in 8 times, plus 48 minus 52. 52 minus 48 is 4. 4 6, but we can reduce that to 8 2/3. So x then is 8 2/3 using the triangle bisector theorem. All right, now this one's a little bit more interesting, the one on the right, in that we're given a measure here of x, but we're given the total length of that base. So this portion right in here, since this is x, this is going to be 20 minus x, right? If that's x, if this first little portion right here is x, then the second portion's got to be 20 minus x. So let's see, we got proportionality here. Let me see how I want to set this up. Let's say we're going to have x over 20 minus x, because those two side lengths are going to be proportional. And if that's the case, again, since I went with the x here, I need to use the 14 in the numerator. 14 over 11. And let's do some cross multiplication. And when we do, we got 11x equals 14 times 20 minus x. Now we need to distribute this 20, that's 14, to the 20 minus x, and now we got 11x equals, let's see, 14 times 20, 14 times 2 is 28, times 10 is 280, minus 14x. And let's add 14 to both sides to get all of our variables on the left. And when we do, we got 25x equals 280. And we're going to divide both sides by 25. Let's see. Well, 25 will go into 28 one time. Let's see, x is equal to 1. And we got 3 left over, so 25 will go into 30 one time. And then we got 5 over 25, which can be reduced to 1/5. And if I put that in decimal form, 1 divided by 5 is 0.2. And so the length of this side right here is going to be 11/2. And it doesn't ask us to solve it, but what is the length of the other side? So I got 20 minus 11/2. So I got 0.8, and then 19, 8.8. Yeah, okay. Persistence, practice, patience, and perseverance.